Okay, hello everyone, my name is Ibrahim and today we are going to pass through question number 83 on chapter 25 Rando, which states we are supposed to find an electric potential at the center of this cylinder. As you can see, this is the cylinder. We are supposed to find electric potential at this point at the center. So what is going to help us is we are going to divide our cylinder into very thin rings like this one. As you can see, it has a very small thickness Z and very small charges dq, and the radius of our ring is r, the same radius as our cylinder. So how is this ring going to help us? If we will be able to find the electric potential of just one ring, we can sum up all the electric potential of the rings at this cylinder, and then we can get the electric potential at this center. So if you revise the electric potential of just one cylinder, just one ring, from the certain point here, our point is center Z, with the ring having a radius Z, we'll have to write it here. Electric potential of a ring from a certain distance, we'll have to take 1 over 4 pi epsilon 0, and then we'll have to take the charge of the ring divided by the distance from that point and the radius of the ring. This is it. And so this is just one ring. What about all rings? But first, let's remove this and make it compatible to the cylinder. We can get dq by taking the surface charge density, which is surface charge density times area of this cylinder. Let's say that we are opening this ring just to find the surface area of our ring. Our ring, if we'll open up to make a rectangle, it will look like this one. It will look something like this one. And this is our very small width, which is dz, and this is our length, which we can get as a circumference right here. First, it was a cycle which has a circumference of 2 pi r. That means in order to get dA, we can just take one length, which is 2 pi r, times another length, which is what? Which is dz. At the same time, surface charge density we can get by taking total charges divided by area. And the same thing happens to area right here. We can get an area by opening this whole cylinder, the area of the whole cylinder. We can open the whole cylinder. Our whole cylinder will be looking like this. And this will be length L, the length of our cylinder from here to here, length of our cylinder. And then this will be the circumference of this cycle right here, just one side. And it will be 2 pi r as well. 2 pi r. So to get A will be equal to taking one side times another side. 2 pi r times length. So let's join it. Let's join this equation right here to and this equation right here into this one to get dq. So in order to get dq, we'll have to take q over a, where a is 2 pi rl. So q 2 pi rl times what? Times dA, which is 2 pi r dz. If you look closely, this 2 pi r and 2 pi r cancels. That means we have q over L dz. This will be our dq, like the charge of this ring, and in correspondence to the whole cylinder. So right now, let's take this equation 1 and let's put it into our general equation 2, V of the ring. So V of the ring right now will be looking like this. V of the ring, 1 over 4 pi epsilon 0. We are replacing the q with this. Q over L dz, all of this divided by z squared plus r squared. Bear in mind that this is just a electric potential of one ring to the center. Okay, so now if we want to find the electric potential due to this whole cylinder, we will have to sum up the all rings which can appear on this cylinder, all rings, which will be infinite rings. The rings will be starting from this side, negative L over 2, to this side, L over 2, as this is a symmetry and the length is L from here to here. And our center, that means it divides our cylinder into two equal parts. That means this is L over 2 and this is negative L over 2. This is negative X and this is positive X. So now we have to integrate this electric potential throughout. So in order to get V of the cylinder, we will have to integrate V of the ring. But from where to where? From negative L over 2 to L over 2, as you can see right here. That means we'll have to integrate our whole equation right here, Q over L dz, and then divide by 4 pi epsilon 0 z square plus r square. From where? From negative L over 2 to L over 2. Okay, let's remove our constants outside. So V of the cylinder will be equal to Q over L 4 pi epsilon 0 from negative L over 2 to L over 2, and then dz over z square plus r square. Let's go back to our diagram. If you'll see our diagram right here, it's a symmetry. Whenever you open it, wherever you cut it, you make two equal parts. I mean, two parts of the same image, two parts of the same image. If you cut through it here, it's a symmetry. So by defining the laws of symmetry, of course, in integration, this lower part will turn into 0, where the constant 2 will shift upward right here. So it will look like this, 4 pi epsilon 0. By the law of symmetry, this 2 has gone into this, and this will turn into 0, and then this L over 2 dz z squared plus r square. Okay, let's define this part right now. Just this part. This is an integration part. So by the laws of integration, if we have something like that, L over 2 0 dz over z square plus r square, by the laws of integration, this will turn into something like this, ln of z plus under root of z square plus r square. Bear in mind that all of this thing, we are going to integrate it in this difference, all over L over 2 and 0. All right? Okay. So let's put our values inside. So at the first, our z is what? L over 2. Then plus L over 2 squared plus r squared. And then at the second time, our z is 0. If we put 0 right here, z as 0 and this is 0, we will just remain with ln of under root of r square, which is ln of r. So let's apply the natural logarithm laws, where we will have this r divided by all of this thing inside. Something like this one. I'm just repeating the same thing, but right now I'll just divide all of these stuffs under r. So what comes next is this r will come to be like L2 over r. This r will enter inside here, so this means it will be equal to plus L over 2r squared, and then we will plus by r squared divided by r squared. This is under root. This is all inside. So let's finish here up. Ln L over 2r plus, this means it will be equal to 1. Don't forget the under root, plus L over 2r squared. So this whole thing right here, turned to be equal to this thing right here. So what helps us right now is just we are going to replace this expression right here, z square plus r square right here. We are going to replace this in this equation right here, and then we'll finally evaluate what is the V of the cylinder at the center. So let's enter it right here. So Q over L remains outside, but right now we had 2QL after applying the laws of symmetry. So 2Q over L over 4 pi epsilon 0. We are going to replace all this thing with just this, the final answer of this thing. So then we will have to multiply by ln of what? Remember to have brackets. Ln of L over 2R plus 1 plus L over 2R squared. And so this will be our final results, our simplified results. That will be the electric potential of the cylinder at its center. The center is right here, and this is the cylinder. Thank you for listening. I'll try to put the PDF on the comments, so try checking it on. If you will not find it, that means I failed to put it on. Thank you.